I'm just sharing my screen with you guys. Please give me a feedback when you will see my screen. Yes. Can you guys see my screen right now?
Yeah, can see.
Okay.
Yes, we do.
Thank you. Thank you. Thank you. Okay. So we'll start with the proceedings with today's main topic, MLOps. And the things we are going to discuss in today's session are, first of all, we'll be discussing what is MLOps, and then we'll try to get our hands-on experience to the TFX or TensorFlow extended end-to-end platform for production level machine learning pipelines. So starting with the definition of MLOps. So if we talk about the software engineering principle or the software engineering side, we have a concept of DevOps, in which we have two terms, development and operation side. So we have a code, we get the code from the GitHub or repository, anywhere we have code, and we'll then try to build it, test it, and run it and deploy it. So the same concept applies here, but in some different terms. In the world of machine learning, we have a concept of machine learning operations. So machine learning operation is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. So now, what is this term of putting our model in the production phase and then looking at its performance? So we have different phases in MLOps. So we start with the design phase, in which we will get the requirements from our customer or client, whatever we have. We look at the problem we are dealing with, and then we get the data for that particular problem. And then after getting the data, we'll move forward to the model development phase, in which we start with the data engineering, in which we build some of the pipelines. You can say ETL, extract, transform, load pipelines. And then after getting the data and formatting by the data engineering team, we tend to go with the model engineering phase, in which where we try to build end-to-end machine learning pipeline, where we train our model. And then after training part has been completed, we'll move forward to the testing and validation. uh, when we move forward, then after the completion of model development phase, we'll tend to go for the operation side, in which we will deploy our model to different platforms available. We will use the CI/CD pipelines for automatic integration and deployments of our machine learning models, and then also monitoring and then triggering whenever there is some kind of, you can say, problem or model decay problem. So we will look at in the part of monitoring and triggering. So here is the whole overview of machine learning lifecycle. So machine learning is not really about the coding part. Like, in you can say, over the scale of 100%, only 10 to 15% of the whole scenario will be in the coding domain. Other than that, we have configuration, automation, data collection, data verification, and then we also have to perform feature engineering on the data set, testing and debugging, resource management. You can see a lot of things are going on here. And at the end, we have also serving infrastructure, where we will be serving our particular model. We have to look at that serving infrastructure also, and then we also have to look at the monitoring of our current deployed model. So we can look at the problem of model decay, data drift, concept drift, etc., etc. So coming to the part of TFX, what is TFX? TFX is, you can say, a framework. It's an open source framework designed by the Google, and it's been used in most of the project in the Google, such as Gmail. Their pipelines are built in the TFX realm, in using the TFX. And if we talk about the TFX, what is TFX? TFX is used to create and manage production scale pipeline. So in TFX, we have different components, where we will try to get our problem solved by these particular component. So we'll move forward to these components. So in TFX, we have these certain components. We'll start with the example gen component, where we'll be getting the data from our, you can say, whichever we have our on file system or from cloud or anywhere. We'll try to get that data and ingest it in that phase of example generation. After getting the data from the file system or the anywhere from we are getting, we will move past the data to the statistics gen components of TFX, which will generate the stats on the data received by the example gen, and then after generating the statistics on that particular data, we'll move forward to the part of schema generation, where we'll be building or looking at the schema of our data set. And after getting the schema generation, and we will move forward to the process of example validator, where we'll be validating our example that we have generated from the statistics generation and then also schema generation, and we'll verify that these schema generation and statistics generation. After the completion of schema phase or example validator phase, we'll move forward to the transform component. In transform component, we will apply some of the feature engineering techniques here, and then after applying these techniques in the transform component, we'll move forward to the part of training component. You can say trainer. Here we will be training our model, and also we have a tuner component where we apply some of the hyper parameter tuning in machine learning models we have. And then after the completion of training phase, we will move forward to the evaluator phase, where we'll be testing our machine learning model against the test data and then evaluate its performance. And so we'll look at the different phases of how to evaluate our model. We'll look at the different, you can say, thresholds or different metrics to look at our performance. And then after getting the required, you can say, accuracy metrics, we'll move forward to the phase of pusher. We will be pushing our model to our desired platform. So in pusher, we have a lot of different platforms are available. Here we have TensorFlow Serving, TensorFlow Lite, TensorFlow JS, TensorFlow Hub. TensorFlow Serving, which we'll be doing in our today's session. TensorFlow Lite is mainly used being for mobile application, and TensorFlow JS is mostly being used in the web realm. And TensorFlow Hub is, you can say, it's like a Docker hub where you have uh, a lot of models available there, and you can try and test on and deploy them in your particular case. So in these components, we have different all of these components are using some TFX libraries. You can say we start with a data ingestion component where we have example gen, and then the component statistics gen, schema gen, example validator. These components are using the TensorFlow data validation library, and a transform component using the TensorFlow transform library, and tuner and training component using the estimator or estimator or Keras model, TensorFlow model analysis using the evaluator phase, and then validation outcome using the pusher components, and then TensorFlow serving is being used for the model serving part. After moving forward, move forward to the part demo part we have in here. So first we'll start with the part of TensorFlow installation, where we have install the TensorFlow, and we'll restart it again. So you can see that applying some changes in here. Perfect. Now here we are importing some of the libraries, the components that I have talked about. TFX components, we are importing the CS example gen, and we have also a example validator, we have schema gen, we have statistics gen, we have transform, tuner, trainer, evaluator, and pusher. So these are these components that we have just talked about, example gen, statistics gen, example validator, and all of these components. And we have just imported the important libraries, and then we are moving forward to the next step of here we are defining a folder for our pipeline with the name of pipeline, and then we are getting the data, our required data from GitHub repository. We are using the Chicago taxi data set for our particular problem. I know most of the examples are available out there using only the Chicago taxi data set, but we are using this just for the baseline so that you can use, and you can use this example for any of the problem you are dealing with. It's kind of a baseline for you guys to use that code and run it anywhere you want to like. And we have just created the directory structure. I'm just going to show you that we have created the directory structure pipeline. We have created a pipeline route. We have the hello. Okay. We are just using the directory structure, and we have created a directory with the name of pipeline, and we have also created a directory with the name of serving model within that particular pipeline folder. Why we have created that serving model directory, I'll come to that part later in the presentation. So we are getting this, we are just looking at the data set that we have gathered, and there are some of the rows that we have gathered data set from our GitHub repository. Now we are, that's the part we are where will be getting our really hands on the TFX side. We are just creating a context, interactive context. It's kind of you can say metadata, SQLite data, so that we'll be using, and getting the data from our previous component that we'll be using in the later part of the our pipeline. So start with the example gen component. Here we are getting the data from data root folder. That's defined we here in the above here, and it's getting the data, it's generated its output artifacts with the name of train and evaluation. So it's kind of you can say a component where it's getting the data from the data ingestion from any platform, and then dividing the data set into two parts. So 66% of the data set will be going for the training phase, and the remaining 33% will be going for the evaluation phase. So we are just looking at the output of this particular components. We have train and evaluation components. I'm just going to refresh this, and here you can see the folder we have created with the name of CSV example gen, and we have just training and eval dataset in the form of TF records. And if we move forward to the next, we are just going to look at the some of the following example that has been generated by the uh, example gen components. So here are some of the top three examples that were generated by example gen component. We have key with the company and its value, Chicago, etc. And we have also a feature with the name of drop off census tract, and its value is in 64 list, and also we have the other remaining features out there. So moving forward to the next step, in which we will be doing the statistics gen, where we will be generating the stats on our training evaluation data set. We'll just move forward to the statistics gen component. Here we are. We have just generated the, if you look at the inputs of this particular component, see components dot inputs, it's getting data from the example gen component. It's getting the inputs from this particular CSV example gen, that the folder that we have just created, and then its output is that it's generating the statistics on training and evaluation data sets. Its output, you can look at, it's available on here, statistics gen, statistics 2. If we just go to the directory structure here, we can see that a folder being created with the name of statistics, and its folder number is around about 2. And if we look at the statistics, yeah, you can see that we have created just two files for the evaluation part, and the training part, just it's created the statistics on training and evaluation data set. So if we move forward to and just look at the statistic data set generated, yeah, we can see that in our data set it has created a beautiful you can say visualization of the data set, in which we have feature four features available with the data type of integer, and we have also variable lengths, we have floats, we have strings, and you can see that a lot of features are out there. And if we just try to look at some of its functionalities in statistics, and we can see that we have a feature with the name of a census tract, and its value has been 10,000, and there is missing value, 0% missing values in that. Its mean is 17, its standard deviation 330, zeros, minimum, maximum, and it's also plotted some of the graphs available. You can just go and then change these values, and look at the way you want to see them, and for your particular problem. So if you look at the tips uh, feature, and we have 10,000 examples here. 0% is missing, and if we look at the this particular column zeros, we have 68.991% of the values are zeros in that particular phase. So we can get that it's pretty biased toward that the figure of zero. I mean, if we give our model a number of features and then 68.9% values are already zero in our data set, it's kind of a bias toward the value of zero. And so we have different statistics on our data set, and we are just moving forward to the next part of schema generation, where we'll be generating the schema of our of our data set. And we have that in it's getting the input values from statistic component. Here we can see that it's getting the input values from a pipeline statistics and statistics to the folder that we have just created here, and it's getting these values. After getting these values, we are just moving forward to the next step of let me just comment it out there. We are moving forward to the part of visualization, where we are just looking at the schema of our data set. We have a feature with the name of company, its value type, its type is string, and it's just telling us that whether it's required in our particular problem or not, and it's telling us its domain. We have a company domain related to it, and it's also telling about all of the other feature remaining out there. We have trip start time, trip start month, trip start hour, trip start day, trip seconds, trip miles, trips, and it's telling a lot of about these feature. It's telling about each of the feature and its type, and whether it's required in our particular problem or not. And then we are also exploring these domains. So if we talk about the domain that we have mentioned here, the company domain, so what is this particular domain company, it's telling us about that. And if we talk about the payment side, yeah, here we have this payment type. We can look at that payment type of different: cash, credit, dispute, no charge, pcard, etc. So moving forward to the next phase of the example validator components, here we'll be validating our examples. If you can see that it's getting the inputs from the statistics component and schema component. It's getting the input from these two particular, and getting the URL. If we look at the URL, it's getting the data from statistics folder and getting the data from the schema generation, and schema with the name of 3 folder. We have these folder here. Yeah, we have these. It's getting these values from these particular folders, and after getting these values, it's generating. It's telling us whether our whether we have any anomalies in our data set. It's kind of whether we have any missing values in our data set. So if you look at our the, the output of this particular component, it's telling that we have no anomalies in our data set. So it's telling us no anomalies found. If you have any of the missing values in your data set, it will show you a warning, or you can say, or error, that you have these missing values in that particular feature. So you have to look at it again and figure out and correct these values, and then again rerun this example validator component. So it will show you that you have no anomalies left in your data set. And it's pretty important for your side when you are just retraining your model. And for example, you have trained your model for a particular problem, and then after several months, your input values or input features changes, and then you will have a difference between the actual trained model and the values that you are getting from the real time for the model prediction. So it will show you those particular you can say use cases, that whether you are getting the values for when you are getting the input values are different from that your model was trained on these values. So moving forward to the next part of transform component, here we will perform some of the feature engineering techniques. And we have defined a file with the name of taxi constants. Here we'll be defining some of the constants. So we have some of the categorical features available out there, in which we have start trip or start trip start date, trip start month, and pickup. We have these features are of the type categorical type, and then we have also some of the features of the fourth type, trip files, fare, trip seconds, and we also some bucketizing some of the features. So we'll try to cop up these features and bring it down to them, bring it and combine all of these features to a one particular feature. So we are just defining our taxi module files. If we just refresh, yeah, we have that. And if we move forward to the transform components of that file, we are defining the transform component of our problem. Yeah, here we are performing some of the feature engineering techniques on our data set. We are just hard coding some of the values. We are applying some of the scaling on our data sets on integer values. We have some TensorFlow values. We are applying some of the you can say feature engineering techniques where we are just scaling these values to z-score, and then after getting these values, we are applying some of the hot encoding for categorical feature types, and after that we are filling these some of the missing, if we have any missing values available in our data set, we are filling those, and we are applying the transform component where we'll be uh, applying some of the feature engineering techniques on our data set, and it is getting the input values from the example and schema generation components, the transform components, the example gen and schema generation components. So it's applying transform component. It will take some time, around I think 1 minute, and after that it will perform the transform component and transformation on our data set. Yeah, it's applied that. If we look at the inputs of that particular component, we are getting the input values from the example gen component, and we are getting the values from this directory csv example gen examples one, the folder that we have just created here, example and one, and it's also getting the input values from the schema gen components. Here we are getting these values from schema, and we have the folder with the name of schema. It's getting these values from schema, the three, and after getting these values, it's generating some of the, you can say, different folders in which we have, it's generating some of the pre-transform stats, and then after applying the transformation on the data set and generating these statistics on those uh, after post transform data set. So it's generating an output of a transform graph. If it's really important for when we are dealing with the rerun, or you can say model versioning, so it will be important for that particular part where we'll be dealing with the TensorFlow graph, and we also have transformed example with the name of folder. We have it's also analyzing the cache side of our pipeline, and pre-transform, post-transform schema, and pre-transform statistics and post anomalies. It's generating a lot of directories, and it's for the transformation phase. Now, if you look at the some of the transform that it has applied on our data set, if you just look at the yeah transformation, some of the transformation that is applied. Yes. Here we are looking at the transform graph of 5. It's generating the transform graph, and after getting the transform values from our data set, it's generating the some of the example. We have split, name, train, and evaluation, and it's also generating some of the transform examples, the things we have talked about, and it's also generating the some of the exam values for our features. And here is the directory structure that we have get recently, TensorFlow for transform metadata transform fn, and after getting the directory structure, we are moving forward to the training phase, where we'll be defining a trainer file with the name of taxi trainer, and we'll be writing our model in here, where we are uh, applying some of the layers. Here we are for categorical columns, we are doing that for for the real world values, you can say if dense float values, we are applying this particular layer for the dense float features, and we are applying these are in our model and classifier model. And after getting that, we are just compiling our model and then generating the summary of our model. And we are also saving our particular model using the serving model directory and that we have just created. We will be getting the model in our this directory. Now we are training our model using the trainer component we have here, and it will take some time to actually train the model, and then after performing the training phase, it will try to evaluate the model. We are just, it's just running. Yeah, the training part has been completed, and
Okay, great. Mr. Hamza, would you like to take some questions now while the model is
I'll
training?
I'll take the question at the end of the session. I'm
Okay.
just going
Okay, perfect.
ending at, toward the end of side of phase.
All right.
So it's generating these folders here. If you look at, yeah, it getting the input values from the example gen component and the transform graph that we have just here with the name of yeah. It's getting this transform graph values and the schema from the schema gen component, and then after the running this particular uh, component is generating the two folders, model and model run, and we'll be using these for when we'll talk about the model server site. And if you just look at the model directory here, it's getting these values of do that we have assets, canvas model, saved model. We have this our saved model in here, and if we run the TensorFlow board for analyzing the performance and in the training component that we have just mentioned here, it's launching it. Yeah, it's running. Yeah, it's giving us the feedback of our training components where we have it's telling us the loss values in the training phase that we have just get, and it's also telling us the fluctuation in our binary accuracy, that model that we have just trained, and telling us about the accuracy on different steps and telling us about the different epochs. So if we move forward to this particular component of evaluator, we have just trained our model and now we are evaluating it against the evaluation data set. We have defined a eval config file with the name, and we are using the binary accuracy metrics here, and we are just configuring a threshold where we are saying that if our model is accuracy if our model accuracy is more than 50%, then we are going to move forward, then we are moving forward to the phase of pusher, and will send our model towards the pusher side. And if it's less than 50%, we are gonna ignore that. But for one particular problem where we are training our model for the first time, we will ignore that particular statement and just look at that and look at the accuracy that we have available for right now, and pass it to the resolver phase where it will look at the its different artifact. And here we are running the evaluator phase. It's getting the input values from examples model, and we are just telling him that if there is any baseline model available out there, compare it with that particular model. If not, then it will be the for the first time that we are running our particular model. Now it's evaluating it against the test data set or eval data set that has been generated in here. In that, yeah, and now it's completed and it's telling us about the evaluation, and we have a evaluator for here. We have a folder with the name of evaluator, and it's telling us about a blessing, whether it is blessed or not. Blessed mean it has passed the requirements that we have just defined in the evaluator phase, and now it's telling us that the model have passed that's metrics, and its status is blessed, and you can move forward to towards the phase of pushing it to the your required or the choice of your model server, and we are moving forward to that particular use case where we'll be just looking at the some of the evaluation techniques that is applied and some of the stats on the evaluation data set. Here we are just looking at the example count that we have total of around about you can say uh, 5,000 roughly, and it's telling us the slice by slice uh, visualization on our data set. And then also we are just looking at the slice by slice data for one feature trip start art, where we are just looking at, we have an example count of around about uh, 400 I think so. And we are just looking at the slice by slice data set that in that particular R we have this for that particular R you can say, or for that particular domain, or for that particular area, we have this number of examples out available out there. And we are just looking at these for our better understanding that whether our model is performing on great on some of slices of the data, and performing worse on some of the slices of the data. So we can visualize that, and it's generating the accuracy value for that slice of the data, and also telling us that you have these strip start are 19, you have the example count of 323, and its accuracy is 64% on these, on this number, where you have a trip start R of 19 and loss value of 45%. And telling us a lot about the other values, right? If we have trip start R with the value of 1 and trip start R with the value of 7, so it is telling us about the binary accuracy, and telling us about the example counts for that particular number, and then telling us the loss value for that slice of the data set. After getting the uh, evaluation, we are just moving forward towards the phase of blessing our model, and push evaluator will send this model to the pusher component, and pusher component will move forward this phase towards the TensorFlow serving. We are using the TensorFlow serving for serving our model in that case, but you can use any of the framework. If you are dealing with the mobile application problem, you can use the TensorFlow Lite. And if you are just building a website and you want to embed a TensorFlow model into your website, you can use the TensorFlow JS. But for our case, we are using the TensorFlow serving. And pusher component will push it to the serving model directly, the model we will be serving the directory that we have just created. Here we have our required model that we are going to serve. We have our saved model, assets, variable, etc. And we are just looking at the pusher outputs, and we are just looking at the latest push model in our serving directory, and looking at it different. And here we are moving towards the phase of TensorFlow serving, where we'll be serving our model that we have just created in that pipeline. And we are just importing the some of the pre-necessary, and getting the permission of sudo. It's using the Debian Linux distribution for in that collab framework. And we are just getting the TensorFlow serving from running the command, and giving the permission of sudo if any needed, and then updating our system in that realm. And after getting that, we are installing the using the apt get install TensorFlow serving. Apt get is a package manager for Debian Linux distributions. And after getting the data from the apt install TensorFlow serving, we are just moving towards environment where we have just created with the latest push model that we have just defined it here. uh, Here we have defined that latest push model, and it's getting the directly structure of that serving model. Now we have just get the environment variables from that, and I forgot to mention one thing. We have just commented out here one thing in the above. We have commented out the one thing. mm, in in the schema gen we have just, yes, we have commented out these values, and it was throwing an error. It was throwing an error. Schema bb2 is not defined. Okay, so I'll come to that part later. So I'm just ending the session with the TensorFlow serving. I'm just getting in some of the error, and I'm trying to resolve this. In the meanwhile, you can ask any question if you have. I'm just debugging this error. If you have any question, you can ask with it.
All right, thank you very much, Mr. Ami Hamza. So we're going to be taking questions now. But your screen is, you're not sharing your screen again because I believe one or two persons
Yeah,
might want to ask
I,
questions.
I, I'll share it again. I'm just making some changes in here. I'll share it again.
Okay, great.
In the meanwhile, anybody can ask. If you have any question, you can ask. Please go on with that.
Okay, so kindly unmute yourself, please, and ask your questions if you have any questions.
Okay. Okay. Okay.
It seems we don't have any questions from the house yet. Hello?
Hello.
Okay.
Yes.
Yeah, I guess there are no questions yet, so maybe we could just move on. Yes.
Okay. Yes. I'm going forward to the next step. And yes, I'm sharing my screen right now again. Okay. So here we are just running our model and presenting it towards the TensorFlow serving part, and we are presenting our model, and we are running it TensorFlow server with a port number of 8510. We have a name. We have named our model death model. You can name it any way you want, and then we are also generating the logs for our model. And here we have some of the logs. Unfortunately, due to some errors, I'm not being able to run it right now, but I'll fix it later and share the notebook with you guys. And here we are uh, making the example a serialized phase, so we can present these example to our model for running the training phase and give us the prediction back. And here we are presenting our CSV example towards the model using the function of do inference, where we are giving the model server address, model name, and the example that we are going to pass. So we have just created the model with the name of death model. And if you want to access the model, you can use the URL https with the host name of 127. We are running it on a local host, so 127.0.0.1, and specify the port number of 8510. And after giving that, we have just embed the version of our model v1 and models. And after that, we are giving the model name that we have just created that model, and then we are just telling our model that to predict these values for these three examples that we have just specified in here. In serialized example that we have just created these three examples, and we are telling our model to give us prediction on these particular example, and it's giving us the prediction values for these examples. So yeah, that's it from my side.
Okay, great. Thank you very much, Mr. Abiyu. That was a very extensive one. I think we have a question from out F4. I can't pronounce that properly. Apologies. The question says, aside from the modeling and deployment phase, we should be able to reuse structure or flow for something like PyTorch. So that's what the question is. The question is saying, aside from modeling and the development phase, can we be able
Mhm.
to reuse the structure or flow for something like PyTorch?
Okay, okay. Now, if we talk about aside from modeling and deployment phase, we should be able to reuse the structure or flow for something like PyTorch. I think they are mentioned as PyTorch. No, we cannot use that TFX realm for the PyTorch, but yes, we can embed our model from any framework. We have PyTorch available out there. We have TensorFlow. Can you talk about? Okay, we have different framework out there available for training our model, so we can use any of the framework out there and embed it on our TFX pipeline, but it will take some time, and it will take a lot of configurations you have to do, and you have to manage a lot of different things because TFX is more of compatible with the TensorFlow model, so it's kind of a more biased toward the TensorFlow model, so it will be really difficult for you to get it in your pipeline for using the PyTorch model. So I will not recommend that approach to use that PyTorch model in the TFX realm. And the next question we have, can you talk about how you deploy the model to different environments from development to production? Say, I have used the TensorFlow serving. You can use, we have different deployment platforms out available. We have TensorFlow serving is one of them. We have NVIDIA Triton Inference Server where you can deploy your model on NVIDIA Triton Inference Servers. We have also Kubeflow serving where you can deploy your model on Kubeflow. It is using it is using Kubernetes under the hood, an orchestration tool for managing the deployments, and you can also use a torch. PyTorch also has an open source deployment. Uh, you can say framework out there where you can use that and deploy your model to that particular platform. Anybody else question?
Okay, great. I guess we don't have any more questions at the moment. And
Okay.
yeah, so I guess the you're going in your benevolence, you're gonna release the slides to us and the code block. So
Yeah, yeah.
because
I'll share these file
oh,
slides and the pipeline with you.
all right, that's great, and that will be communicated to all the participants. So since we don't have any questions, I guess we the webinar will come to a close because it's just a 1 hour series, and I believe um, we have been able to have a solid knowledge or to broaden our knowledge in terms of understanding TensorFlow and TensorFlow components. And we will
Yes, yes.
build on this knowledge we've gained today and use it in our machine learning development and
And
production pipeline. Thank you so
one
much.
one thing one thing to mention here that due to shortage of the time, I was not able to convey all of the concept very, you can say, deeply or in a very sophisticated manner. So if you want to go on and explore it your by self, I will recommend the, if you want to really run the TensorFlow serving, you can go towards the Coursera and MLOPS specialization launched by deeplearning.ai. I would recommend that you to go towards the Coursera and watch these videos and get on hands-on experience on that particular specialization, because you are going to learn a lot of different things on this from this specialization, not the TFX but also other than that TFX. So it's really a good specialization according to my understanding. So if you are interested in TFX, you should go with that specialization. I would recommend that.
All right. Thank you so much. I really appreciate everyone for joining in into the webinar, and we hope to see you in the second edition of